So hi again, everyone. Thanks for being here. Our guest today is Elena Popa. She's a fellow graduate from the Central European University, and she is assistant professor at the Asian University for Women in Bangladesh. And she works mostly on the philosophy of science with a special emphasis on causation, counterfactuals, causal models, and related issues. And today she's going to talk to us about agency in artificial intelligence. Hand it over to you, Elena.
Thank you, Danny, and thank you everyone for the interest in the talk. I'm going to share the slides with you. So the topic for today is agency in artificial intelligence systems, and I'm going to propose a teleological approach to that. This is a brief outline. I'm first going to give you a little bit of context for this discussion and my argument, and explain the significance of the topic. Then I'll be discussing the concept of autonomy in artificial intelligence systems and its connection to human goals in particular. Afterwards, I'll look at the debates on whether there is such thing as agency in AI systems. And again, I'm going to look at the importance of human goals and particularly arguing that if there is such thing as agency in AI, then human goals will have to be part of it. Fourthly, I'm going to present an argument for the teleological approach to agency in AI that I'm defending, in contrast with other approaches that I'm going to call roughly non-teleological. So in terms of the significance of this, recent debates in AI ethics include concepts such as responsibility, moral agency, autonomy, and one thing to clarify here is that autonomy is used in several ways. I would like to clarify that I'm going to use the term autonomy in a technical sense, in a sense that's used in engineering, in relation to the behavior of artificial systems, and not in the sense that it's used in moral philosophy or political philosophy. So in this technical sense, the autonomy of AI systems is expected to increase. And then the question is, if we're going to have these AI systems with more autonomy, how are we going to discuss their behavior within an ethical framework? So my argument would go against what I call naturalizing agency. So the scare quotes are there because while I don't want to go into the debate over various strands of naturalism, I will be critical of some of the claims associated with naturalism, particularly this focus on some features of the behavior of such systems, especially the micro level things that characterize their behaviors while leaving out things such as human goals or intentions. And the point here, which is made in the literature, is that leaving out the human side to it leads to misattributions of responsibility. And this is present in a debate between Floridi and Sanders on the one hand, and then Johnson and Miller on the other hand, on the question of artificial moral agency. Now, against this background, my claim is that if there is agency in AI, then we have to consider human goals as being part of it. That will further imply that the study of AI behavior will involve teleology, and this can help address the issue of responsibility. As mentioned before, these debates are taking place in an ethical context. There's not so much talk about artificial agency more broadly, but there's talk about artificial moral agency. So my aims here are to connect these discussions to philosophy of action. So if we're talking about moral responsibility, we are talking about agency, we are talking about action. So how do we explain action in the context of such entities? Then the other thing that I'd like to do is to define artificial agency outside of the moral debate at first, and then explore the ethical consequences. So this can be seen as providing an ontological background for discussions of artificial agency in moral or social philosophy. So one clarification to make here, because you might have seen the title, the abstract. I'm talking about AI agency. This is connected to responsibility. So one very debated issue in AI ethics is this question of self-driving cars and situations like the trolley dilemma. So I want to clarify that this is not what I'm going to talk about. Why? Because these self-driving cars, as assumed in these examples, are not autonomous in the sense that I'm interested in. So in these debates, the idea is to program the car such that if faced with a moral dilemma, it should behave according to the ontology or to the consequentialist rules. But this behavior is completely coded by the programmer. So it's not, so to speak, learned by the machine. So my discussion would apply to more advanced kinds of AI than this. So now I'm going to explain what autonomy in AI is. Just to say that again. So autonomy here refers to a technical feature of these systems. And even in the literature on AI and engineering, its meaning is not agreed upon. And I think that generates some confusion and some further debates that philosophers in particular could explore. So this is a distinction drawn in the context of artificial life or A life. But I think the broad features can apply to any kind of AI systems. So there's the first understanding of functioning without human intervention. And any kind of engineered system could work like that, even if it's, let's say, using something like a remote control, that would count as autonomy in this sense. So this is not a very strong sense of autonomy. Then there is the sense of acting to achieve goals or even set one's own goals in the context of a certain environment. And this is the teleological notion that I'm going to be interested in. And then thirdly, there's the sense of autonomy as robustness and flexibility of behavior. Now, more recent work, also on the topic of artificial autonomy, distinguishes between so-called low-level attributes that include perception, actuation, learning, context awareness, and decision-making, and high-level attributes that include domain independence, self-motivation, self-recovery, and self-identification of goals. Again, goals are present here, and they're also present as part of the higher-level attributes. So again, artificial autonomy is understood in different senses with lower-level and higher-level components. Now, again, just to contrast this with the case of self-driving cars, self-driving cars would have autonomy in the first sense, according to the distinction drawn earlier, or in the sense of low-level attributes. So the code is supposed to provide this knowledge to the car a priori. So in this sense, the car is not learning this behavior by adapting to an environment or by setting goals in any way. So as mentioned, my interest is rather in sense two and then high-level abilities, particularly this idea that a system can be considered autonomous if it is pursuing goals. And in this context, one question that arises is whose goals are those meant to be? In previous work that I've done, and this is in relation to a life or artificial life systems, I have argued that these goals are ultimately human goals. So they characterize human interests that are part of the research program that enables such design. Just to give you an example, so a case study that I've used earlier. So there is this organism that's called the xenobot that's been completely engineered. So there's an in silico design that is used on cells from a species of frog that's called Xenopus laevis. And yeah, this is a completely engineered, completely new organism. For those of you that have an interest in the philosophy of biology, I think this particular example does raise questions regarding, for instance, functions. So this is a biological organism that has biological functions, but it has no evolutionary history. So yeah, that's something that I think deserves further reflection. For my purposes here, I'm quoting the author's explanation of the significance of synthesizing such organisms. So I'm going to read only the highlighted parts out loud. So to deliver drugs inside the human body, to help with environmental remediation, or to further broaden our understanding of the diverse forms and functions life may adopt. As you can see, all of these are human goals. So if we are designing, if we're synthesizing such organisms, the idea is to fit goals that we have in relation to medical uses or environmental uses or increasing our knowledge. So all of these goals are connected to human interests. So to wrap up this first section, the preliminary conclusion is that when you talk about advanced levels of autonomy in artificial systems, you talk about goals, but then these goals are very clearly tied to a research agenda that is set by humans. So I'm going to move on to the other topic of agency in AI. And in order to do so, I'm going to say a few things about agency more broadly first. So the so-called standard theories of agency hold that an agent performs an action only if an appropriate internal state of the agent causes a particular result in a certain way. Just to give you an example, let's suppose I'm going to the kitchen to get a cup of coffee. In terms of explaining my action, you could say that I went to get a cup of coffee because I wanted a cup of coffee. So desires, or because I believed that there is a cup of coffee still in the kitchen. So beliefs or desires would be enabling me to perform the specific action. And in this case, that requires a representation of the desired state, so of me drinking coffee. The issue here, so many authors have raised, is that there are cases where agency does not necessarily involve representation, and the standard theory does not capture that. Now, on the other hand, there's another view that is traced to Dennett, but that's been used in another context. I'll call it instrumentalism, following the Stanford Encyclopedia entry on agency. I think, yeah, other authors have used different names for it. The idea here would be that you can attribute agency to a system if it behaves as if it would have intentions, goals, desires, and so on, regardless of its innards, as Dennett would have it. So regardless of whether it has this inner mental states or not. And now, if we want to apply this to the particular context of AI, we see that the standard theory doesn't work because AI systems would not have the ability of working with representations, but a kind of instrumentalist might work because, yeah, it's more permissive in the sense you look at the behavior. If it behaves as if it's pursuing a goal, in that case, we can say that it has agency. And I'm now going to look at two examples of theories of artificial agency. So the first one is by Floridi and Sanders. Again, to add a clarification here, Floridi and Sanders talk about artificial moral agency. So this is, again, a more complex kind of issue. I'm only going to focus on the agency aspect. So I'm not going to talk about morality. Floridi and Sanders come to this view by the levels of abstraction approach. So the idea would be that you can look at these entities from different levels of abstraction. So at a relatively low level of abstraction, you could include things such as beliefs, desires, consciousness, and so on. So these things that apply to human beings, but then at a higher level of abstraction, you would be able to grasp this without looking at the human-specific features. And Floridi and Sanders considered that this is relevant for explaining artificial moral agency. So the three features that they associate with this are interactivity, that amounts to the relation between the artificial system and its environment. Autonomy, which is slightly different from what I was talking about earlier. So it's the weaker sense, so ability of operating on its own without human control. And adaptability, which involves learning from previous interactions, but essentially balancing interactivity and autonomy. So interacting with the environment, but at the same time maintaining certain kinds of behavior, certain kinds of acts, regardless of the environmental conditions. So now this view has been subject to criticism, particularly from Deborah Johnson. She is arguing that AI systems have moral aspect with regard to their behavior. So this is why they should be considered moral entities, but they do not meet the conditions for being moral agents. In a subsequent article with Miller, a further claim is made that the levels of abstraction approach that Floridi uses leaves out social aspects. However, these social aspects are central to attributions of responsibility. So if you leave out the social dimension of AI behavior, then you're going to have a problem when we discuss responsibility. I'm going to have a little bit more to say about this, but that's going to be in the next section. For now, I'll move to the second approach to agency. So this is called minimal agency, defended by Parandiaran and collaborators. And minimal agency is defined in terms of three features. First, there's a system as a distinguishable entity that is different from its environment. Second, the system is doing something by itself in that environment. And thirdly, it does so according to a certain goal or norm. You can see some similarities to Floridi and Sanders. So you have an interaction with an environment and you have the entity being distinguishable from that environment and doing things, again, on its own. But notably, you have the addition of goals or norms. So this is where you could include, let's say, social considerations, normative claims, and other ethically relevant aspects. And yeah, notably, this doesn't involve mental representations. And yeah, the further thing that I'd like to note here, if the goals according to which the artificial system is acting are human goals, then they are in a way dependent on human agency. So these entities came about through human beings working on a certain kind of research project and then are doing things that serve human interests. Without pursuing this, one issue that I would like to point out, if it seems attractive to talk about agency, in this stronger sense, that would apply to human adults, so which would involve consciousness, mental representations, and so on. And in this weaker sense of, let's say, minimal agency, instrumentalism doesn't seem to have a way of distinguishing these two. And again, this might be a problem, especially, in relation to responsibility, but maybe in relation to other issues as well. So now, bringing the discussion together regarding autonomy in the second section and then agency in the current section, it seems to be the case that the issue of whether AI systems have agency applies only to those systems that possess autonomy in the sense of higher level abilities. So this idea of maybe pursuing goals, identifying goals, and so on, and not so much working on their own without direct human intervention. So that would be a lower level of autonomy. Insofar as such systems are not readily available right now, this question seems to be relevant in relation to future developments of AI. So building a kind of ethics before such systems are around. All right, so now moving to the next section, the question of the teleological versus non-teleological approaches to AI behavior. I'd like to point out two assumptions that would lead to views on AI behavior that are not teleological. So when I say not teleological, I mean that they're not taking into consideration human goals. So if they talk about goals, then those would be somehow reducible to the way in which the system works. So there are two assumptions here. One of them is the reduction to lower level entities. And this is something that you can find, for instance, in reductive physicalism, but also as a strategy that seems to work for the levels of abstraction method as well. So the idea that you have this higher level property and then you look at lower level constituents that would lead up to it. And then secondly, the idea of explaining away purposes or goals. Now, this is more broadly a feature that characterizes modern science. And yeah, in terms of seeing where these debates take place, I think the use of functional concepts in science is relevant, particularly with regard to biology. Now, I'm going to explain that these assumptions are false, at least, yeah, insofar as we're talking about the behavior of artificial systems. So first of all, reduction to lower level entities. The first issue here is the critique raised by Johnson and Miller, particularly against Floridi and Sanders, but this might be extended to other non-teleological approaches. Relevant moral and social aspects, such as what the system was intended to do, are left out if you're only looking at the lower level operations that explain the behavior of such system. And then in addition to this, some of these relevant social and moral aspects are not reducible to lower level physical entities. So they amount to, let's say social needs or maybe dynamics of power. If you think, for instance, the relevance of AI in a field such as labor. So these are all higher level processes that you cannot reduce to lower level physical, but maybe not necessarily only physical entities. All right, so now the second assumption is explaining away purposes or goals, and I'm going to contrast it with biological uses. So in the case of biology, when you talk about adaptation and functions of various traits, it looks as if a trait has been designed for a purpose, but actually the way it works is that you can explain it through a process such as natural selection or other types of selection, and they all come down to biological processes. So it looks that way, but actually there is another explanation that you have in the biological process that underlies all of this. Unlike in the case of biology, for AI systems, this is not merely a metaphor. AI systems are designed to do the things they do, to exhibit the behaviors we see them doing. And if they don't, it means that they weren't properly designed or something went wrong at some point. So yeah, in the case of AI systems, it's not just the as if for purposes or goals, but rather they do work according to such goals. So now it seems to be the case that in non-teleological approaches, you have this assumption being brought together with the first assumption of reduction. So assuming that behavior can be reduced to lower level operations. And we have an additional problem here that these operations cannot all be managed by the designer. So this is a feature of advanced AI systems. So in that case, we can no longer pin down the important variables when assessing such behavior, particularly for moral assessment. A little side note here in connection to Danny's talk in the beginning of the seminar series. So is this spooky teleology? If you accept goals, so if you reject the assumption that science does not work with goals or purposes when you talk about AI behavior, And you say, okay, this is something that we do in biology, but it doesn't make sense to do it for AI behavior. So when we talk about teleology for this particular case, how spooky is this? So I would say that the spooky element to it is that it is non-reducible. So we have particularly, social aspects that would be part of understanding these goals. So now I'm going to point particularly difficult problem for for teleological approaches to AI behavior, then explain how teleological approaches can address it. So this is known as the responsibility gap, discussed by Matthias in an article from 2004. This is a summary. I'll go through it quickly. So the programmer becomes a creator of software organisms and does not fully know and cannot completely check the exact coding. Then the behavior of the machine is determined by its environment to a large extent, perhaps more so than by the initial conditions. Then there's a blurring of the distinction between programming, training, and operation, and complete human control over each operation performed by the machine is impossible. The result being that there are certain behaviors that we could say, okay, this AI system is responsible for doing without being able to place the responsibility on maybe the engineer that's operating it or on the designer and so on. So my argument here is that this gap arises on non-teleological approaches because they assume responsibility to come down to lower level tasks that are fulfilled by the machine without considering the overall goals or norms that it is supposed to abide by. So when you look at this higher level of abstraction, these levels of abstraction language here, you're going to miss things such as goals and norms, and you're only going to look at these operations insofar as we as human beings cannot control all of these or cannot even understand all of these operations. Responsibility seems to be vanishing. Now, before I introduce my argument here, I'd like to point out that this has been subject to criticism from other directions as well. So Tigard, for instance, discusses this from the perspective of moral responsibility and explaining how our concepts of moral responsibility change according to new circumstances. So yeah, the responsibility gap is an active subject of debate, and there are objections to it as well. So before I discuss a relevant example in relation to this, a little bit more information about the teleological view I'm defending. So judgments about responsibility and artificial agency need to take into consideration two conditions. One of them I've already explained. Human goals that the machine in question is meant to fulfill are central to this assessment. To this, I'm going to add another condition, a background of other norms and values that the machine should not undermine. So the behavior is meant to achieve some goal, which is human set, but then achieving this goal should not undermine other types of norms and values. This is a bit abstract right now. I'll illustrate with an example in a moment. So this is an example that was initially discussed by Matthias. So there's the Abo dog, which is basically dog-like AI system. It's not using machine learning right now, so it's used as a more advanced toy that children can play with. But let's suppose it gets to the level where it uses machine learning and it develops its own behaviors by interacting with the child, with its environment, and so on. And let's suppose that as a result of that, it learns to run around the apartment. The child is also running, and something happens that they collide, and the child gets injured. The question here would be, who is responsible? According to Matthias, the AI system itself, so the Abo dog, would be responsible for that. So that would be it in terms of making the assessment of responsibility. You wouldn't have any person that would bear the responsibility for that. Now, according to my analysis, this doesn't work. And in order to show why it doesn't work, you need to look at human goals. So what were the goals that the machine was meant to fulfill? Entertaining the child. So far, so good. But then we look at the second condition. You have other norms and values that the machine should not undermine. You have the issue of safety. Now, I don't think that this example is particularly strong, but then I wasn't that convinced with the other examples in the paper either. Because I think even if you talk about toys that are less advanced, I think safety is an issue. So then when you talk about responsibility, then obviously you talk about designers. So, okay, entertaining the child is the idea of designing this AI system, but this shouldn't come at the cost of safety, right? And then again, maybe this gets approved somewhere. So who approved that? Did they check the relevant variables, safety being one of them? Supposing they happen to overlook safety, you still have to incorporate this, I don't know, when you launch the next version, or you take all the AI systems of this kind off the market. But I believe you can make this point only if you take into consideration human goals and then, other norms and values that we associate with the usage of these systems. So now I think this shows a bigger problem with AI responsibility and non-teleological approaches, connecting to the black box way in which they function. So here is the more broad argument that could be made with regards to not being able to attribute responsibility in these cases. So premise one, explaining what goes wrong with AI behavior involves knowing all the operations performed by the system. Premise two, those operations are opaque. Therefore, one cannot explain what goes wrong with AI behavior. So if explaining behavior, and especially what goes wrong about behavior, comes down to operations which are not intelligible to human beings, maybe we will never be able to understand what was wrong and then who was responsible. Now, if you go to a teleological version, however, things get a bit more complex. So, I've added another premise here and revised premise one a little bit, and then we get a completely different conclusion. So explaining what goes wrong with AI behavior involves knowing the design. So this would be the input part, and then the operations that are performed by the system. Then number two, the same as with the previous argument, the operations performed by the system are opaque. Nevertheless, I've added, premise three here. The goals involved in the design are intelligible. So we cannot grasp each and every action that led to the whole machine learning process, but we can grasp the design and its goals. Therefore, one can at least partially explain what goes wrong with AI behavior by looking at what it was supposed to do. So when you see the discrepancy between the output, so what happened and what it was supposed to do, you know that something went wrong somewhere, and then on the basis of the design, you can infer further information from that. So you don't need to understand each and every operation that the system is performing. This has been basically the fourth section. Now I'm kind of moving towards the concluding part. I'm first going to explain some correspondences with approaches in the philosophy of action. So the way I've explained artificial agency renders it dependent on human agency. And the meeting point for these two types of agency would be goals. So artificial systems cannot set their own goals, but those goals are set by humans. And then what goals humans achieve by the means of artificial intelligence is something that, can be analyzed in the context of human agency. Now, this is not logically incompatible with the standard theory of human agency. You can technically have any approach to human agency. Still, I would like to point out a connection with teleological approaches, particularly my critique of assumptions regarding reduction and then explanation through lower level entities. Teleological approaches are also critical of that. My view is also critical of that. So I think there is a connection there. There's also possible tension with a particular branch of teleological approaches. So those would be inspired by the work of Wittgenstein, for instance, that would simply consider AI systems to be artifacts, and then saying you cannot talk about agency in this case. People behave in a way, these machines behave in a way. There is no connection between these two. Now, I agree with the substance of that, but I think it is useful to have a concept such as that of minimal agency, if for no other reason, at least to be able to discuss these issues across philosophy, engineering, policy. But that would, basically be another topic. If you have questions on this, I'll be happy to discuss more in the Q&A. Now, in the broader context of philosophy of science, the question that I raised earlier, whose goals, has still not fully been answered. So I've referred to human goals, but then not all people have the same kinds of goals and interests. So taking into consideration the goals and interests of different groups would be part of the discussion of this. Issues such as deliberation and transparency have to be taken into account when you discuss this, from a broader perspective of science and society, and this is done in current scholarship on the field. Now, one thing that I would like to mention with regard to naturalism in particular, because I've been critical about it so far, I don't think my view is incompatible with naturalism either, as long as it doesn't involve this idea of reduction. So an example would be Philip Kitcher's approach to ethics. So Kitcher uses this framework of an ideal conversation, so how problems can be settled within this framework. And Kitcher argues that this is something that has been used since early human societies, and it's been like technology, so to speak, to solve social problems. So my view would be compatible with this kind of naturalism. And again, so talking about goals and interests and subjecting them to deliberation. All right, so the concluding slides, autonomy and agency applied to AI systems involve human goals, according to my arguments here. And the fact that they have been neglected by current approaches to this can be explained through assumptions regarding reduction and explaining away teleological notions. My further point is that a teleological approach is needed to capture the adequate degree of complexity that we need for responsibility attributions. These are the references. Thank you everyone for your attention.